Hey there, folks. All right, so I hope you loved those conversion notes yesterday. Today we are going to be taking measurement notes. And a few things before we get into that. First of all, please note that your quiz this week is on Thursday, not Friday. There is no school this Friday because of parent-teacher conferences, so your quiz will be on Thursday. Okay, so it's already on Schoology. But I'm telling you now, I'm going to tell you again tomorrow in class on Wednesday, Thursday, weekly quiz. So watch out for that, okay? Secondly, we're going to do a little bit of practice for conversions from yesterday before we get into our measurement notes. So this is the unit conversions worksheet number 2. This is in your guys' big packet if you want to follow along. I'm going to do a couple problems here using the 5 steps we talked about yesterday. So we're going to start with this one right here. 4,200 grams equals how many pounds? Well, as always, I want to start by writing my original value over 1. So 4,200 grams over 1. Now, what do I need to use next? Well, I don't want grams in my final answer. I need to be able to cancel it out. And the only way to do that is if I have grams at the bottom of one of my upcoming conversions. So I know that this has got to be a gram right here. Okay? Now, what can I convert grams to that gets me closer to pounds? Well, I can convert them into kilograms. So 1 kilogram equals 1,000 grams. So if I have 1,000 grams on the bottom, I have 1 kilogram on the top. And again, to kind of re-emphasize, well, how do you know it's 1 over 1,000 instead of 1,000 over 1? Well, if you focus on the units, okay, so again, I focus on the fact that grams need to be on the bottom. And you look at this like, okay, the 1,000 goes with grams. That will really help you determine whether it's 1 over 1,000 or 1,000 over 1. So don't ask yourself, what fraction am I using here? Ask yourself, where do the units belong? And that should really guide you safely to exactly the right math, if you will, when you're doing these conversions. So there go grams. Those are gone. I don't want kilograms in my answer either, though, so I need to make sure I cancel those out. So I need kilograms on the bottom of the next one. I can convert kilograms straight up to pounds, which is what I want. So 2.2 pounds is equal to 1 kilogram. So here we go. Kilograms are now gone. Boom, boom. I now have the units that I want in pounds. So I know that I'm done with my conversions. So I multiply all this through. So 4,200 times 1 times 2.2 is 9,240. 1 times 1,000 times 1 is 1,000. And now I just need to divide vertically. 9,240 divided by 1,000 is 9.24, and those are pounds. Those are pounds. All right, and I'd like to do one practice problem with a distance. So we're going from kilometers to feet. And by the way, you will always be given this table right here. So when it comes to quiz time on Thursday, everything inside of here you guys have available to you. So I'm going to literally copy and paste this exact picture of this table. So as long as you know how to use this table, you're gravy. Okay, so I'm starting with 12 kilometers. I want to go to feet. So I'm going to start by writing, my initial value over 1. So 12 kilometers over 1. I know that I want kilometers on the bottom of my next measurement. Okay, so I got kilometers on the bottom of my next one. If I want to get closer to feet, I can convert my kilometers to meters. Again, I'm using this guy up here. So I got 1,000 meters over 1 kilometer. Okay, so there go my kilometers. I don't want meters either, though, so I need to have meters on the bottom of my next one. Well, I can convert meters into centimeters. There are 1,000 centimeters in every meter. I'm sorry, 100 centimeters in every meter. So those are gone. And now I'm going to use that distance gateway. Remember, if we have a distance and we're going from American units to standard units, we're always going to have to go through here at some point. So 1 inch is equal to 2.54 centimeters. Again, is it times 2.54 or divided by 2.54 here? Well, let the units tell you. We know that centimeters need to be on the bottom, and it's 2.54 centimeters is equal to 1 inch, not the other way around. So boom, those are gone, those are gone. We still don't have the units we want because we want feet, not inches. Oh, there goes the bell. And so we need inches on the bottom of the next one. 12 inches is equal to 1 foot. So there goes that, inches, boom, boom. And now we have the correct units, we have feet. So we're going to go ahead and multiply through. So what does this all equal? 12 times 1,000 times 100 times 1 times 1 is 1,200,000. 1 times 1 times 1 times 2.54 times 12 is 30.48. 1,200,000 divided by 30.48 comes out to be 39,307.1 feet. Mr. Pilcher, do I have to have that 0.1? Be like, it's not really that big of a deal right now. We're actually going to talk about sig figs later down the road to tell you exactly where to end a measurement, or I'm sorry, a calculation. But we'll worry about that later. So for right now, if you put 39,307, that's fine if you didn't include the 0.1. No big deal. All right. So that brings us to our measurement notes. So I'm sure that I'll talk more quickly than you can write at a lot of points during this video. So make sure to just hit that pause button, or you can hit spacebar to pause YouTube videos. Whenever you need to, make sure you catch up. Okay? So measurement. What exactly does that mean? When we measure something, what are we talking about? Well, a measurement is a comparison to a standard. Okay? It's a comparison to a standard. So this is kind of like the control group idea from scientific experiments. It's like, well, how do we know what we're dealing with, how fast something was, or how slow it was, or how tall it was? Well, we need to compare it back to some sort of standard. So that's what any measurement is. And originally we think of the foot. So how we used to measure things, well, you take the king, he'd be like, all right, this right here, can you see that? It's my shoe. Okay. That is going to be our standard. So when you're measuring a horse, you want to talk to me about how many of my feet long that horse is. But you can see how that's really weird and arrogant, first of all. And secondly, well, what if like King Henry I has giant feet, and then he dies young, and then his like 13-year-old son becomes ruler, and his feet are like half the size of King Henry. So now all of a sudden your 25-foot carriage is 48 feet. And you're like, but it's the same carriage. But like, well, no, it's 48 feet now, so it's going to cost you a lot more. But like, what? But that doesn't. Why do we do things this way? And so you can see how that was kind of an issue, and that sort of brought in the need to have some internationally recognized units. It's like, okay, what, the King of Spain's feet are bigger than the King of England's feet. It's like, I don't know what to do. So that brings us to SI units. SI units are the System International. In other words, this is the internationally recognized system for measurement across the world. So universally accepted standard for all math and scientific measurements. So these are the units that you'll use if you move to China, to Australia, to Scotland, to South Africa. It doesn't matter. These are the units that are accepted in the scientific community, no matter where you go. Okay? So instead of gallons, the world recognizes liters to measure volume. Instead of our American pounds, the world recognizes grams to measure mass. Talk to me about that Fahrenheit, baby. Like, well, nowhere else outside of America do people care about Fahrenheit. So Celsius is the universally recognized value for temperature. And lastly, don't give me miles, inches, feet, all these random numbers. Talk to me about meters if you want to talk about any length or distance. Okay? So these are the standard international units of measurement across the world. And again, I love America, but our units are terrible, okay? How long's a mile? 5,280 feet, Bob. Be like, okay, that is just such a random number. It makes no sense. It's so much harder to work with. Why would we do it that way? And the rest of the world sees our units and they're like, nah, we don't want any part of that. And so these are the units that they're going to use. And so that brings us to the SI unit conversions based on these prefixes, okay? So these prefixes down here, they will go before one of these units, like liters or grams or meters, whatever. So for example, let's talk about liters, okay? So you could have a kiloliter or a deciliter or a milliliter, a milliliter. You guys have probably heard of that one before, I hope. And so these prefixes go ahead of the word to explain how big it is. And that is important for a lot of reasons. So for example, if we're talking about measuring your bathtub, you might want to do that in just regular liters, okay, if you want to measure the volume of your bathtub. But if you want to measure the ocean, if you do that in regular liters, that's going to be a ridiculous number. Versus if you do it in kiloliters, that'll be a less crazy number. And so these prefixes kind of allow us to adjust the size of our measurement to sort of fit what we're doing in particular. Now in here, I have the letter B, stands for base unit. So this is where your liters, your grams, your Celsius, your meters, this is where they are on this scale, okay? So we're talking about a regular meter, not a kilometer, a millimeter. That would be right here at B for base. Okay, now, so how we do these conversions if I want to go from centimeters to kilometers or something like that? Well, you can use this chart to do that. So I'll use a different color here. So let's say I'm going from centimeters to kilometers. I find the centi right here. Here it is. And I want to go to kilometers. So there's two things I'm going to keep track of. How many spaces do I have to move to do that? And which direction do I have to move to do that? Well, if I'm going from centi to kilo, that's going to the left. It's going to the left. And how many spots is that? Well, that's 1, 2, 3, 4, 5 spots to the left. Okay, so here's how this works. We find the decimal, and we're going to move it 5 spots to the left. So we got 1, 2, 3, 4, 5. So that means our decimal will be here. Like, Mr. Pilcher, what do we do with these empty slots? Well, what number looks like it fits perfectly in there? A 0. So you put zeros in these empty slots if that ever comes up. So what this is really telling us is that 50 centimeters is really equal to 0.005 kilometers. Let's try another one. Okay, so we're going from liters to milliliters. Remember, liter is a base unit. So that means we're starting right here at the B for base. And we're going to milli. So again, count how many spots you have to move and the direction. So I'm going from here to milli. So it looks like I'm going to go to the right. And how many spots? 1, 2, 3 spots to the right. So if here's where the decimal is in 15 liters. I'm going to go over 1, 2, 3 spots to the right. So my decimal will now be over here. And I'm going to drop in zeros in all these empty slots. So 15 liters is really the same as 15,000 milliliters. Now, a lot of people like to memorize this chart. So you've probably heard of King Henry dies by drinking chocolate milk before. Whatever acronym floats your boat. Yeah, whatever works for you, works for you. But this is how you can do these quick conversions. You can also use a chart like the one up here if you want, but this doesn't include everything. So it has kilometers and meters and millimeters and centimeters, but it doesn't have like deca or hecto, so just kind of watch out for that. Now let's talk about errors when we're measuring on this second to last slide of notes today. So one thing that's really important for you to keep in mind is that all measured values contain some degree of error. All measurements, no matter what, contain some degree of error. So you're talking about electronic balance, a stopwatch, a graduated cylinder, a ruler. It doesn't matter if you're measuring it with your eyes, if you're using some sort of electronic tool, there is an error involved. And why is that? Because at some point, you have to guess. So you remember reading graduated cylinders. At some point, you had to guess there. And the moment that you guess, or estimate is what we properly call that, you're no longer sure. So yesterday we talked about, okay, keep measuring until you estimate exactly one time. Well, once you estimate one time, you're no longer sure. If you're no longer sure, that means there's a little bit of error creeping into your measurement. It might not be a lot, but it's there. All measurements have an error. And you're like, well, what about electronic balance? So what if when I put something on this balance and it's like, yep, that's 59.6 grams, baby. So like, oh, it's 59.6 grams exactly, Mr. Pilcher. It's perfect. Like, nope. What this machine is really telling you is that it knows for sure that the mass of whatever it is 59 grams, and it's pretty sure it's 59.6. But that machine is like, oh man, I mean, I'm not going to bet $1 million on it. I got other little mini electronic scales to feed. I don't know. Oh man, that was a bad joke even for me. Yeah. Well, anyways, the point is that this 6 is estimated. It's not for sure. There's a little bit of error introduced there. even with an electronic device. One important idea. So this is an idea you've seen before. You always estimate to 1/10 of the smallest place value of the device. So with a graduated cylinder, each one of these tick marks is 1 milliliter. So we need to estimate to 1/10 of 1 milliliter. In other words, we need to move back 1 decimal spot to estimate. So this is a fancy way of saying move back 1 spot to estimate. So this scale knows for sure the ones place. That means you need to go and estimate to the tenths place, 1 spot behind that. And here's a key idea. How do we know when we're going to estimate? Well, that depends entirely on the device. That depends entirely on the device. The better your device or measuring tool, the further your measurement can go, the smaller the error becomes. Okay, and that's a really big idea. So let's go ahead and I'll just show you a couple things. This is the activity that we would have done. Now you guys have this worksheet right here. You can feel free to print it off. You also have these rulers on another page of your big packet. I printed these rulers where there's a blank page behind them. So that way when you print it off, you can cut them out if you want to do this activity. It's pretty useful, I think. So take a look at these two rulers, okay? These rulers are the same thing. They just aren't as, one is not as good as the other. So you see how this ruler only goes by tens, whereas this ruler goes by ones, okay? So if I were to measure the side of this rectangle with this ruler, I'd look at it and be like, okay, that's definitely in between 10 and 20. But then is that like 11 or 12? Like, you know, I think that that's probably about 12 centimeters, okay? So maybe you measure this side and you're like, okay, I think that's about 12. But let's change our tool. So let's move this guy out of the way. Let's get this guy in place right there. Okay, so when we're measuring with this better tool, this better device, we look at this and be like, okay, well, now I know for sure it's in between 11 and 12, so I know that this is 11 something actually. And I can even estimate, like, that looks like about 11.8 maybe. So we look at this, be like, okay, how come our measurement changed? Did the length of this rectangle change? Be like, no. Did my eyesight change in between measurements? Be like, no. What changed? Our tool, our device changed, and that's what changed our measurement. So our measurement, where we estimate and how precise our measurement is, depends totally on the tool. So we got 11.8 with this tool. We got 12 with this tool. And it's not that anything changed about this rectangle. It's simply we changed the measuring device we're using. Okay, folks, make sure you go right below this video and take that lecture quiz right now before you forget. And I will see you guys in class tomorrow. Don't forget the weekly quiz is on Thursday. I'll see ya.